So today our topic is sets. Okay, so sets. So first take an example. So we are taking an example. Suppose all the students of class 11, as you are in class 11, so all the students of class 11 in your school, in your school, in your school. So what can you say about this? Like all the students of your in your school of class 11. So there are some names like you are there, and say Ram, Sham, okay, and like this, and there are many students, okay. So now take a any student from this collection. This is a collection, obviously this is a collection, right? This is a collection of students, right? So now take a student, uh, take a student from class 12, a student from class 12, okay. So let take a student from class 12, let call it Amit, okay. So he is a student of class 12. So can we find this name in this collection? Can we find it? So yes, so we cannot find this name in this collection. So that means this is an, we are calling it an element, calling it and or named it an element, and this is a collection, let's say it a set, okay. So we cannot find Amit in the above set. So for the timing we are calling this collection as set. This is a collection of students, and this is, we are named it a set, and this is an element. But if we talk about now, let we take another element, say Ram. This is another element, Ram. Is Ram in the set? Let to be more precise, one second, to be more precise, let name it a set, okay. This is a set. So is Ram another element? We are taking Ram, and is he in the set A? Yes, this is true. So Ram is in the set A. So now we are introducing a symbol. This is the symbol, okay. This is the symbol. This symbols means belongs to or is in, এরপরে কিছু একটা sorry, is in, and after that some set will be there, okay. So this symbol is belongs to. That means Ram is in the set A. So we denote Ram. This is a statement. Ram is in the set A. ঠিক আছে? O- Okay. So Ram is in the set A. We denote this statement symbolically like this. Ram belongs to A. Okay? Acha. Uh, okay. So we have already seen that this Amit, this element Amit does not belongs to the set A. So we are writing Amit does not belongs to the set A. How will we express this statement in symbol? So we will express this statement in symbol like that. Amit does not belongs to set A. This means does not belongs to. This symbol means does not belongs to. Does not belongs to. That means Amit is not in set A, right? Okay. Now, so now come to the definition of a set. Now we can define a set. Definition. So you have seen that a set is a collection. A set is a well defined collection of objects, and this is the definition of a set. So but intuitively we cannot define a set. It is a intuition, because you have to apply intuition to understand the sets. And what is the collection, sorry, what is the objects? Here objects means the things you can perceive of. Means you can think which objects you can think, and they can form a set. Okay. And here the word well defined means, what is the meaning of this word well defined? This means that well defined well defined means we can surely conclude that an element is whether in the set or outside the set. Okay. Well defined means if you are given an element, you can surely tell that either that element will be in the set or that element will not be present in the set. There cannot be both true. That means either the element is in the set, and as well as simultaneously the element is not present in the set. These both cannot happen. Okay, this is the meaning of well definedness. Okay, তাহলে now come to sets and their. Okay, before that let us take some examples of sets. Now take more examples of sets. So examples of sets. So tell me this, whether these collections are set or not. So we are taking, let's say, the numbers which are divisible by 2, and next take the team members of Indian team played in World Cup final of 2023. Okay, so and next, let us take more examples. Now, number 3, most talent, sorry, talented actors in Bengal. Take 4, all. So tell me which of these examples are sets and which are not, and give reasons. Is number 1 set the numbers which are divisible by 2? Is this collection makes a set or not? Is this set or not? It is not a well defined set, a well defined collection. Why? Why this is not a well defined collection? Okay, that's a separate question. That infinite numbers are divisible by 2. But if we take now, see the difference. you are talking about infinite numbers of integers or numbers, whatever we say, that are divisible by 2, right? That's a separate question. But if I give you a number, suppose 0 or 2 or 4 or 6, so it is equivalently saying that a number is even or not. So if I gave you a number, to be more precise, that I am giving you a natural number. So I am giving you a natural number. So let 15 is a natural number. So I am giving you. So can you say that it is even or odd? Yes, it is odd. So it is not divisible by 2, right? So I am taking a collection of sets. Okay, I am taking a collection of sets. Let us suppose, we will come to that. Let denote it by capital A, that is the numbers which are divisible by 2, or in other words are the numbers which are even. So this is our equivalent statement, right? The number which is divisible by 2, that is called even. So let's take 15. I am giving you 15. So tell me, 15 is 15 in the set, let call it set. Okay, this is no, so stop. I will call it, uh, we have not yet decided that it is a set. The collection, this is a collection A. Is this set collection 15 in the collection A? No. So symbolically we can denote that 15 does not belongs to A. Okay, so 15 does not belongs to A. So symbolically this is the correct statement. 50 does not belongs to A, the collection. Okay. Now tell me whether 16 is 16 in the set, in the collection A. Okay. So 16 is in the collection A. So this is true. So if I give you any number, so you can say that either a number. Okay. So if you are given any number, any number, to be more precise, natural number. Let us, for a time being, we are restricted in the natural numbers. So we are talking about natural numbers. So you are given any natural numbers. Do you know that it is either even or odd? It is either even or odd. Do you understand that? It is either even or odd. Yes, it is either even or odd. So if it is even, then it belongs to the set, belongs to the set, not set, collection A. And if it is odd, it does not belongs to the collection A. So there any ambiguity about the number, whether the number is in the collection or not? Is there any ambiguity? So if we divide a number, any natural number, by 2, then it will be fully divisible by 2, or it will left remainder 1, right? That is why any natural number is either odd and or even. So if that it is even, then it belongs to the collection A. If it is odd, then it does not belong to the collection. So is there any ambiguity that if I give you any number, you cannot say that either whether it is in the set or not? There is no ambiguity, right? So this is a set. This makes a set. If there is a not any ambiguity, then it is a set, because it is a well defined collection. Because it is a well defined collection, that is why the collection A is a set. The collection A is well defined. Well defined aggregation of numbers, or more precisely even numbers. So this collection makes a set. Okay. Okay, now second example. Second example is saying the team members of Indian team played in World Cup final of 2003. Now tell me why it is a set. Yes, this is a set. This makes a set, and this also makes a set. Now tell me the what about the example number 3? Most talented actors in Bengal. Good. Why this is not a set? This is not a set. Like how it is not well defined. I want to ask that because what is the because there is no definition of well non well definedness, because how you can say that it is a not a well defined set, right? Different people can put up different perspective. Okay, so this is not a set. So now tell me about what about the number 4? So number 4 is a set because it is an well defined set, because the books which are written by Rabindranath Tagore is a collection, and it is well defined, because if we take any book or novel or poems, either it is written by Arun Tagore or written by other writers. So this is a set. And number 5, all the people of a particular city. Okay, so this is not a set. Okay, so because this is not a set, because um, if I have forgot to add the word that at a particular time, at a particular city and a particular time, because I haven't add this phrase. So all the people of a particular city, because suppose a man lived in a city in 1990, now he does not live there. Okay, so if you take him, now he is not in the city, but once upon a time he was in the city, right? So this is an ambiguity, this makes an creates an ambiguity, so this is not a set. Okay. Okay, if I give you a statement like that, all the people of a particular city at a particular time, that would make a set. Okay, this will not be a set, because these two are same logic. Okay, these two are same logic. And now say, what about the number 7? This is a set, right? This is a set because all the collection of a prime number, because a number is either prime or composite number, right? So this is a set. Okay. So you have understand the examples of a set. Now come to some notation. Okay, notation. Okay. Usually we denotes the set with uppercase alphabets of English language. Okay, and the elements of a set is denoted by the lowercase alphabets of English language. Okay, so with the uppercase letters we denote the sets, and with the lowercase letters we denote the elements. Like, what is the example? For example, X is an element and it belongs to the set capital X. This is an element, okay, and this is a set. This is a set, and this, what is this sign? This sign is belongs to, means this element X is in set X, capital X. Okay, and if we denote that A does not belongs to, like this, capital A, that means A element is not in the set capital A. Here also this is element and this is set. Okay, now the set of numbers. The set of numbers means, because these sets are usually does not changes. This is um, this is convention that we denote n by n the set of natural numbers. You know what are the natural numbers? Okay, and after that z by the set of integers. What are the integers? Which numbers are integers? What are the natural numbers? Yes. Okay. After that, this is the Q, the set of rational numbers. Okay. After that, and sometimes the set of irrational numbers is denoted by I. Okay. The set of irrational numbers. So I is the set of irrational numbers, and the set R. This is the set of real numbers, and I have written this sequence means for the time being, say n is bigger than a sorry so for the time being, say z is bigger than n, q is bigger than z, I is bigger than q, and r is bigger than I. So this is not a true statement, or this is a vague statement, but you can say for the time being you can understand that n z contains more element than n, q contains more element than z, and I contains more element than q. Okay, and r contains more element than I. After after some time we will study the subset and see that everyone is subset of the previous, the later one is a superset of the previous one, or the previous one is a subset of the later one. Okay, so and after that there is also one another number system, that is the set of complex numbers. Complex numbers, and there is some notation, like if we denote z plus, that means it will denote the natural numbers, and if you denote the z minus, that means it will denote the negative integers, and same for the q. And if you denote z star, that means it will denote the non-zero integers, that means the zero is deleted from the whole set of integers, and this is the sets of numbers. Okay, and these three are also for q, I, R, C. Okay, these three are also applicable for Q, R, C, and this is not applicable for N, because the set of natural numbers is also positive and non-negative, and it does not contain zero. So these three notations is invalid for the natural numbers. It is valid for the other these these five sets. Okay, now the representation of sets. Okay, now the representation of sets. Representation. তুমি কি খাতায় টুকছো? নোট করা অভ্যাস নাকি? নোট পড়া? হ্যাঁ হ্যাঁ ঠিক আছে, হ্যাঁ ঠিক আছে, বই পড়বে, ঠিক আছে, বই যে এম এল আগারওয়ালের বইটা আছে ওটাই পড়বে। যদি কোনো লাইন বা কোনো পোর্শন যদি বুঝতে অসুবিধা হয় তাহলে মেসেজ করে পাঠাবে, বলে দেবো ক্লাসে, বা ওখানে যদি বলা সম্ভব হয় হোয়াটসঅ্যাপে বলে দেবো, তাহলে তুমি বেশিরভাগটাই বইটাই পড়বে, ঠিক আছে? There are two types of representation of sets. One is roster form and another is tab set builder form. Okay, these two types of representations of sets are there. So what is the roster form? Roster form is if we enumerate or write the elements of the set in a sequence, like the set of even numbers. The set of even numbers less than 20. Okay, this is a set. Let this is a set, and always set are denoted in the curly brackets. Okay, this is the notation of the set. This is the curly brackets. These two are curly brackets. In between, the sets are represented. Okay, so A is the set of even numbers less than 20. So if we write this set like this, 2, 4, 6, 8, 10, 12, 14, 16, 18, oh sorry, not 20, so like 18, up to 18. So this is the set A in roster form. Okay, and we have already introduced the set builder form. This is the set A in set builder form. That means if we write the elements of the set sequentially with no repetition, okay, then this is called a roster form, the set in roster form. And if we write the set in two curly brackets such that there is a there is one common property that is shared by the elements of the set, and if we write that statement, that will be set builder form. Okay, okay, like if we write like this, so like say set B is like that, all the natural numbers less than equal to 100. So this is set B in set builder form. Okay, and if you write like B like this in the write the elements of the set explicitly like that, 1 2 3 4, like dot 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 dot, dot up to 100. This is the roster form. Okay, you have already seen that to write in the roster form is tedious work, because we have to write explicitly the all the elements, and the set builder form is very much easy and convenient. So we will use the set builder form, and everyone uses that, the set builder form, to denote the sets. Okay, now one more thing, we does not write one element in a set two times. Okay, that means this is not a set one one one. If we write one three times, and after that two times, after that three two times, or four five six two times, seven three times, like that, this is this set. If we take a collection like this, and if we write B dash is like this, 1 2 3 4 5 6 7, these two are same, and this is acceptable, this is not acceptable, because if one element is repeating in a set, we will not write it. Okay, if it repeats more than two times, we will not write it, we will write it only one time. Okay,